Hi everybody, it's Mrs. Dunn. We're talking about linear correlation and regression today. My last screencast of the semester. I'll bet you're really depressed. So anyway, let's get started. So the first thing we're going to do in this screencast is we're going to understand what linear correlation is all about. We're going to look at a specific example. I'm going to show you how to calculate a linear correlation coefficient using your calculator. There are formulas in your book. In MyMathLab might direct you to use those formulas. I strongly suggest you don't. The calculator is the best way to do this. We're going to understand what linear regression is all about. We're going to use the calculator to find the line of best fit. Once again, I'm showing you how to do this on your calculator. You have the technology, use it. And we're going to use that line of best fit to make a prediction. All right, let's get started. This is a very calculator heavy section. Make sure you have your calculator next to you so that you can mimic what I am doing in this screencast. So, is there a correlation between this data that I'm giving you below? So what we have is some data about how many workers call in sick on a specific day and how many defective parts are created when there are a certain number of workers absent. So is there a correlation between defective parts and how many workers are absent? You can see the real world relevance of information like this. You're going to collect this. This is called bivariate data. You'll see that maybe if you read the textbook. Bivariate means there's two variables, the number of workers absent and the number of defective parts. So what we're going to do is make a scatter diagram of this information. To do that, we have to enter it into our calculator. So press Stat, and you're going to use the edit menu and you're going to put the data into your calculator. If there is information already in there that you want to clear out, you're going to highlight the list. So make sure that the list 1 is in black. Press clear and press enter, and that will clear anything that's below. Let's do that for list 2 as well because we have to clear this out. Clear and enter. Don't press delete. That'll screw everything up. Don't do that. So we're going to put in list 1 the number of workers absent. It's important that you put that in as your independent variable, list 1. You'll see that later. That goes in list 1. So I'll put 3, 5, and press enter. And I showed you how to do this before, so I'm going to pause the video and just finish this filling in the data. Okay, so I got all my data in the calculator. You want to make sure it matches up. You have to have 3 and 15 across from each other, 5 and 22 from this list, right? So make sure the data matches up. Make sure you have it all in there. We have 6 pieces of data. Just make sure you entered it correctly. Okay, so the next thing we need to do to create the scatter diagram, and this was just me showing you in the PowerPoint what this looks like when you enter the data. But the next thing we're going to do is draw the scatter plot. Okay, so there's 3 sections here. We're going to do this first, this second, this third. Let me show you what I'm talking about. All right, so once you get all the data in there, press quit. So that was second and quit to get out of there. And now what we're going to do is we're going to access the stat plot menu. So we're going to press second and y equals to get stat plot. And we want this to say on and only this one. Okay, so we're going to press enter for the first plot. Make sure on is highlighted. Make sure that this choice is highlighted. This is a scatter plot. This was a line graph, a histogram. We don't want any of those. So we want this dot, the scatter plot. The X list, I'm sorry, I must have pressed something wrong. So the X list should be list 1. If it doesn't say that, you can access list 1 down here. So you press second and 1 for list 1. make sure the Y list is list 2. So this is what I was talking about before. List 1 is your independent variable, and list 2 is your dependent variable. You expect that the number of defective parts is dependent on how many workers are absent. That's what you're actually testing. You can make the mark whatever you want. I chose the square, but you can choose a plus sign if you want. It doesn't matter. And press enter. Now, once you have all that in there, the next thing you want to do is you have to change your window. So remember, our window is typically set up, if it's the standard window, it's typically set up to go from -10 to 10, -10 to 10 on the y-axis and the x-axis. But that's not going to work for this data. The x-axis are these values. So the smallest value is 0, the biggest is 6. I like to go definitely, I'm not going to go lower than 0 because negatives don't matter, but I'm going to go above 6. So I feel like 10 is pretty decent. I'll leave it at 10. Now for the y values, and make sure you skip down to the y values, the smallest y value is 7 and the biggest is 30. So you'll see I went from 0 to 40. You can really set it to whatever you want it to be. And now I'm going to press graph and look at that graph. And that's the scatter plot. I have it saved on the PowerPoint. So that's all these points. This point 315, 07, this must be 07, this must be 112, 220, 315. I'm just looking up here at the information that we were given. All right, so do we feel like those are correlated? So let me give you an example. Here are some examples of some correlation. This is the strongest positive correlation, because if we were to draw a line through these dots, we could draw a straight line that would go through and touch every one of these dots. So this has the strongest positive correlation. This one has the strongest negative correlation. This is positive because the dots are going up, but this is negative because the dots are going down. So we're going downhill when we read it from left to right here. That's why this R value is -1. R, by the way, is the correlation coefficient. We're going to figure that out on the next screen. So here, the dots all seem to be going up. But if I was going to draw a line, it couldn't possibly go through all of these dots. So this is a pretty strong positive correlation, but not as strong as this one. And then the dots are even more spread out, but still positive here. Here, it's a big old mess. And you'll see similar examples here. This is a big old mess. Doesn't look like there's any correlation. This is less correlated, more correlated, the best correlated, but these are all negative, meaning they're decreasing. Okay. Another way we measure this correlation coefficient is we're going to find out what this correlation coefficient is, and we're going to use this chart to determine whether or not we have correlation. The first column is the number of data values. And then we have alpha equals 0.05 and alpha equals 0.01. If you're going to be taking a stats course, a lot of students that take liberal arts math end up in a stats course. And if you end up in a stats course, you're going to see a lot more of this in stats. So you'll learn a little bit more about this. We're just sort of touching it in this class. All right, so I know this seems like a lot of information, but I promise you it's going to all come together. All right, so is there a correlation between the defective parts and how many workers are absent? We have to find this correlation coefficient, and then we're going to compare it to the chart. To find the correlation coefficient, we're going to actually do this on our calculator. I forgot to mention we're going to compare it, this R value, to the chart, and in this case we have 6 pieces of data. It's going to come up later. Don't worry about it right now. All right, so the first thing we're going to do is we're going to have the calculator do linear regression for us. So this is the screens, and I've labeled this 1, 2, and 3. So we're going to do this first, then find the linear regression, and then we're going to fill this value, this information in third. So First thing we need to do is get to this menu. So we're going to press the Stat key once again. We are not going to be editing, we're going to be calculating. So we toggle over to the Calc menu, and we have to toggle down to Linear Regression. Press Enter. That brings up this screen. And we put our independent variable in list 1, our dependent variable in list 2. Frequency should remain empty. For now, let's store the regression equation. We could store it in our calculator. We'll just skip that for now. And we'll press Calculate. And I have this screen on the next PowerPoint screen. So this value right here is the correlation coefficient. If this didn't come up for you, you might want to go to your mode and make sure that the diagnostics are on. So Stat Diagnostics, make sure that says on. If it doesn't say on, put it on. In fact, if you don't see this on this menu, another way you can get to it is to press the Catalog button. And then you can toggle down to Diagnostics. So you can just scroll until you see the word Diagnostics. Where is it? And make sure you highlight Diagnostics are on. Press Enter. Okay? That way, that menu is going to show up. So if you didn't see it, those are two ways that you can get there. So the correlation coefficient is 0.92. Your book is going to give you this wacko, crazy formula for calculating this. The best way to do it is to use the calculator. Now we're going to compare that to this chart. So our correlation coefficient is 0.92. So we're going to look at the row that corresponds to 6 pieces of data. We have 6 data points. So for a level of 0.05, we have 0.811. So, and for a level of alpha equals 0.01, we have 0.917. So 0.92 is higher than both of those. So it's higher than the most strictest confidence level we have, which is 0.01, which means there is less than 1% chance that we are wrong when we say these two variables are related. So the correlation coefficient is 0.92. All right. I might as well show you here that this linear regression function also gave us the line of best fit. So this is the equation of the line that best fits this data. So we asked for it in this y equals ax plus b form, and it told us A. A is 3.229, blah, blah, blah. I rounded it to 3.23. And B is 8.52 when I rounded it. So the equation of the line is y equals 3.23x plus 8.52. Here's what that line looks like if we were to graph it on top of our plot. So it's a pretty good line, right? See how this best indicates what this direction it's taking. Now we can use that line to make a prediction. How many defective parts will be made if 20 workers are absent? This is an estimate of what we predict to happen. And we just quite simply plug 20 in there. Remember, 20 is the number of workers absent. So we're going to plug 20 in for X. When we plug 20 in for X, we get 73.12. So that's approximately 73 defective parts. That's basically everything you need to know in this section. But let's take it one step at a time here. So, linear regression. So what we're going to do is, this is new data. We're going to draw a scatter diagram of this data. We're going to determine the value of R, rounded to the nearest thousand. That's the correlation coefficient. We're going to determine whether a correlation exists at the alpha equals 0.05 level and alpha equals 0.01 value. If there is correlation, then we'll find a line of best fit. So first you're going to have to put that data in your calculator. So, and you're going to make a stat plot. So remember how you do that. You press stat and edit, and then put the information in your lists. I'm going to pause the video and do that now. Okay, so once you have all that data in there, you can't forget this, guys. This is really important. You have to change your window. So remember we had the window set from 0 to 10, but this data doesn't go from 0 to 10. This data, the X values, start at 13 and end at 100. So I'm going to start at 10 and go to at least 100. I'll go to 110. There's no right answer here, except that you want to make sure each of these values is represented. The Y values, the smallest is 15, the biggest is 60. So I'm going to start at 10, and I'm going to go up to 65. And then we'll look at the graph. So this is the graph that's showing here. And you can see this is not showing. It definitely looks like it's positive, but it doesn't look as strong as our other diagram. Okay, so the next thing we're going to have to do is find this correlation coefficient. So we'll press the stat key again. We're going to calculate the linear regression. Everything is still the same. We'll press calculate, and we have a correlation coefficient of 0.73. The closer this is to 1 or -1, the better our, or more closely correlated our data is. So let me say that again. The closer this R value is to 1, the more correlated our data is. So here we have 0.732. Let's compare that to that chart. So 0.732, once again, we have 6 pieces of data. So we're looking at values of 0.811 and 0.917. And 0.732 is less than those values. It's smaller. So there is no correlation at the alpha equals 0.05 level. And there is no correlation at the alpha equals 0.01 level. So that means there isn't any, or there isn't correlation. The correlation does not exist. And so we wouldn't find the line of best fit because there isn't any correlation. All right, good luck. If you have any other questions, please don't hesitate to ask.